So here we're going to talk about continuity. Now our definition, our old definition for continuity, kind of the definition that we give high school students or middle school students if they're studying this, and that we give early level college students, really at what I would consider more of that high school level, is that continuity is defined as being able to sketch your graph out for most purposes. It's being able to sketch a graph such that when you sketch the graph, you never have to lift your pencil. I'm going to write it like this. Let's just write a create a sketch of a graph without that's the intuitive version of it. Okay, so things that are not continuous. So these are examples of not continuous or uncontinuous or discontinuous functions. One of them might be a situation where you have a single point that's been removed. So we call this point discontinuity. And that happens when you've got a situation where you have a single point that's been moved up off the graph, just like this, so that if you were to try to draw from left to right, you would have to jump up, hit that point, and come back down. Now in this case, let me just share with you what's going on. In this case, let's call this A and let's call this B. And let's call this C. So f at C, the function evaluated at C is a height of B. The limits as x approaches C of f of x is equal to A, right? As we come from both sides, we approach this height value of A. So these guys are not equal to one another, therefore it's discontinuous. When they are equal to each other, it'll be continuous. So let me give you another example since it's not continuous, and then I'll show you our continuity and our actual definition for continuity. So it could also be the case where you are going over to a point and then your function is jumping. Okay, so I always like to think about this as if I had to get up to the next point, or if I had to go along the graph, I'd have to jump to get up here. So sometimes they will call this jump discontinuity. In this case, let's say this is A. Let me use different letters than I did over there. Actually, I'll use the same ones, but I'll just use them in the right order that I used them over here. So we'll call this C, we'll call this A, and we'll call this at a height of B. So f at C is equal to B, right? The height value, since this guy up here is closed, is B. The limit, though, as x approaches C of f of x does not exist, right? So what do we need? What kind of picture do we need for continuity? Well, for continuity, we need a situation where, let's call this C, and let's call this, we'll call it A. We need a situation where the limit as x approaches C of f of x, okay, this is the function f, right? The limit as x approaches C of f of x is equal to A, and guess what? F at C is also A. So since these guys are both equal to A, we can say that they're equal to each other. So in general, the limit as x approaches C of f of x has to be equal to the function evaluated at C. This right here is your definition for for what continuity means. So you see that in continuity, you have to have the limit from both sides in order to, and it's got to be equal to the actual function value in order for you to have continuity. If it's not equal to each other, then you have either jump continuity or discontinuity from a point.